Lesson 14, Summarizing a Distribution Using a Box Plot. Example 1. A box plot, or box and whisker plot, is a graph that is used to summarize a data distribution. What does the box plot tell us about the data distribution? How does the box plot indicate the variability of the data distribution? Here is a dot plot of the estimates of the times it took students in Mr. S's class to get everyone to school one morning. Mr. S suggested that to be sure everyone had the same picture, statisticians developed a standard procedure for making the cut marks for the sections. Mr. S wrote the following on the board. To make a box plot, first find the median of all of the data. So a dot plot is great because it already organizes all of your data least to greatest. The first thing I'm going to do is count the number of dots in the dot plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Remember, a median's job is to cut the data in half so that there's an equal amount on both sides of the median, an equal amount of data points. When I take 27 and divide it by 2, I get 13 and a half. Because we have an odd number of numbers, that means there's only going to be one median. So I'm going to count in 13 dots from each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The median number should be 15. Let me double check that there's 13 dots on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Beautiful. So my median is 15. That's where you start with your box and whisker plot. Draw a line where 15 is. That indicates your median. Next says find Q1, the median of the bottom half of the data, and Q3, the median of the top half of the data. Okay, so I know that there's 13 numbers on this side, which is the bottom 50% of the data, and 13 numbers on this side, which is the top 50% of the data. When I take 13 and divide it by 2, it's 6 and a half, okay? Which means the lower quartile, or Q1, is going to have 6 numbers on both sides of it. So I'm going to count in 6 dots, 1, 2, 3, 4, 5, 6. This would be the middle dot, which would mean there would be 6 on the other side. 1, 2, 3, 4, 5, 6. That's great. 5, 6, 7, 8. So the Q1, or the lower quartile, is 8. Now I'm going to put 8 down here just so I know. And you know what? I might as well circle them while we're at it. Okay? Now I'm going to find the upper quartile. And once you find how many are on both sides on the lower quartile, that's what you use on the upper quartile. 6 in is going to be Q3. 1, 2, 3, 4, 5, 6. I almost... 6 on that side. That means this middle data point is going to be your Q3, or 25. Okay, now there should be 6 on the other side. 1, 2, 3, 4, 5, 6. Beautiful. We've separated it. Now these 3 lines represent Q1, the median, and Q3. Once you have these 3 lines, you connect them with a box. I'm going to be a little technical here. Just make sure it's the very best math I'm demonstrating for you. Okay, this is where 50% of your data lies. Okay, so let me make that clear once I finish the box and the whisker plot. The lower extreme, or lowest data point we have, is 5. That is also called the minimum. The maximum data point we have is 60, and that's called either the maximum or the maximum value. And once you have them, you draw lines from the box to the point. These are the whiskers. That's why they call it a box and whisker. This just separated your data into 4 sections. 1, 2, 3, 4. It's like you're taking 100% and you're splitting it into 4 equal sections. So this whisker would be 25%. This box is another 25% of your data. This box is 25% of your data. And this whisker is 25% of your data. So questions I could ask you are such. What percent of the data is greater than 15 minutes? Greater than or equal to 15 minutes? Hopefully you would understand that greater than 15 minutes would be this percent and this percent together, which is 25. Okay? So that's a box and a whisker plot. Okay, now I'm going to let you and your partner try this example on your own. Okay, the only thing I will tell you is that you have to make sure the data is ordered least to greatest, and it already is. Okay? So I'm going to check my work with this work right here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. 9 divided by 2 is what the median's doing. It's cutting all your data in half, is 4.5. I can't cross out half a number. So I'm going to I'm going to try not to do it crossing out. I want to have 4 numbers on one side and 4 numbers on the other, which gives me a median of 35. I'm going to put a line here. Okay. Then I have 4 on the lower 50% and 4 on the upper 50%. 4 divided by 2 is 2. So there's 2 here and 2 here. My lower quartile, or Q1, is going to be somewhere in between here. When I add these two together, it's 46, and 46 divided by 2 is 23. Okay, so I'm going to find 23, and I'm going to put a line, and I should also circle 35. Now 2 here and 2 here for my upper 50%. In between 40 and 42 is 41. I'm going to draw my third line here, and I'm going to put 41 here just so the people reading my graph can tell the numbers, and I'm going to connect it with a box. My lowest value is 20, so I'll put a dot. My highest is 44, and then I'll draw my whiskers. So now what I'd love you to do is draw your own box and whisker plots based on the problems here. Let's start with number 1. If you did your work correctly, here is what your answer for number 1 should be. Now let's go to exercise 2. Here is what your box and whisker plot should look like for number 2. Just to throw in a side note, remember, each section is worth 25%. This box and whisker plot is really useful because it can tell you which section of your data has the greatest variability, because it's really going to be the longest section. I would say that this section, and this section seem to be very similar in length, which means they're very similar in length of variability. But in between 65 and 72, this is a very small section. There's less variability in this 25% of the data. Let's move on. Please try number 3. Here is what your answer should be for 3. I wouldn't be surprised if you were confused on this problem, because your minimum and your quartile 1 or lower quartile are the same. Therefore, when you graph them, they actually have to be put on top of each other. That means that 25% of your data has very low variability. Actually, it has no variability. Because remember, this is going to cut your data 25%, 25%, 25%, 25%. This lower 25%, they're all 9s. It doesn't vary at all, okay? That's why you put them on top of each other like that. Okay, let's move on. Please try number 4. Please check your work for number 4 with this screen right here. Let's move to number 5. Please check your work for number 5 here on this screen. And we've reached the end of today's lesson. If you would like to start your homework early, you may.